Okay, so good morning. We'll continue our discussion on motion curves. Okay, so we'll take a couple more of problems, and with that, we'll be concluding the topic of motion curves. Okay, I have two interesting problems for you today. Okay, so today's so in the at the end of today's session, okay, so we should be able to analyze the motion of the particle by plotting the motion curves. Okay, so in the previous session we had discussed about what was motion curves, and we had discussed about the acceleration time, right, velocity time, the displacement time, and the velocity displacement curve. So these are the four predominant curves which are there, which we will be seeing, okay, in case of when we are discussing about motion curves. Okay, now in the previous session we had discussed about it. Okay, so we had discussed about three particular criteria, where first of all, when we have a case about uniform velocity, right? Suppose if I'm having my particle, which is that particle, it is moving with uniform velocity, then how I can plot the acceleration, okay, on a graphic, in the graphical mode. Then how I can plot the velocity, and how I can plot the displacement. And same ways for firstly for uniform velocity condition, then for uniform, when I have uniform acceleration, and then when I have variable acceleration. So there we saw that when it is uniform velocity condition, there and that time my displacement, it is directly proportional to value time. Okay, so it is a straight line with a positive slope. Okay, then when I have uniform acceleration, then it will be x, my displacement, that is directly proportional to the square of time. It's a parabolic curve, which is a, and when I'm having a case of variable acceleration, so in that case, the acceleration is directly proportional to time. So obviously, my velocity, it is directly proportional to t square. So that means the velocity, it will become a parabolic curve, and my displacement, which is that becomes a cubic curve. So this was what we had discussed, and we took a couple of problems. Okay, we took a problem about it. Now, today we'll continue that discussion. Again, we'll take another couple of interesting problems which are there. Now, here I am given the velocity time graph here. Okay, and from the velocity time graph which is there, I am supposed to find out what is the distance traveled in the first 10 seconds, firstly, then the total distance which is traveled in 50 seconds, and finally the retardation. What is meant by retardation? The other terms which are, they are fine. Retardation, yeah, it's a different term. So, what is retardation? Can you tell me?
Decrease in something.
Also known as deceleration. Okay, reducing acceleration, which is there, that is known as retardation, right? So here in this, if I seeing the velocity time curve, okay, so in which phase which is there, in which time duration is my particle which is there, in which time duration my particle, it is having a reducing velocity, or which is having a retardation, it is having in between times t equal to 20 seconds and t equal to 50 seconds, right? So that is what is meant. I am supposed to find out the retardation. So when I'm talking about retardation, then how much it is going to be my acceleration in that phase. Okay, so now firstly we'll be in my first case is then I was supposed to find out the distance traveled in 10 seconds. Now what is my graph given here? My graph given here, that is my velocity time graph. So from the VT curve, how can I find out the distance from the VT curve? How do I find out the distance?
Area
The area under the curve,
under the
and
graph.
that the area under the curve for that particular region, right? Now, if I am no, see, if there are actually two cases here. Now, firstly, one case which is that the total, if I am supposed to find out total distance traveled in 20 seconds. Secondly,
Hello. Am I audible?
yes,
Yes,
sir.
sir.
Yes, sir.
No, there is a power outage here. Okay, so that's why I'm the laptop which is there. It just shut off directly because it does not have battery backup. Okay, so please wait here. Do not leave the meeting. Okay, I'll see to let me see. Okay, to join back. Okay, so as soon as the power is back, okay, so I'll be joining maybe in 5 minutes. Okay.
Okay.
Okay, sir.
Okay. Anybody have you taken the screenshot of the question?
Yes, sir.
Okay, fine. So do one thing then.
Yes,
If it's
sir.
okay. So if it's possible for you, then present yours. Have you taken the screenshot in mobile or laptop?
Mobile, sir.
Okay, then present the screen.
Okay.
And yeah, give me a minute. I'll be back. Okay. Yes. So for my question, which is there, okay. So in the region between my particle, which is there, in the region between 0 to 10 seconds, which is there, in that region, the particle which is there, that is accelerating, right? So because I'm in the velocity time graph, which is there, okay. So please share the screenshot. स्क्रीन रोटेट करना पड़ेगा बस स्क्रीन रोटेट करना पड़ेगा yeah fine that should be fine yeah so here in the region between 0 to 10 right so in the region between 0 to 10 my particle which is that is accelerating right and what is the my velocity time graph in between 0 and 10 what is the nature of the graph there hello
It's accelerate.
no yeah I'm asking you the nature of the graph in between 0 to 10 the velocity the nature of the graph in between 0 and 10 what is the nature of the graph there
positive slope.
It is a straight line, right? My velocity
Yes.
time graph, it is a straight line, right?
Yes.
मुझे वो आंसर चाहिए ना. हम नेचर ऑफ ग्राफ बोलने से क्या आपको बोलना है? It is a straight line with positive slope, straight line with negative slope, right? It's a parabolic curve, it's a cubic curve. वैसे बोलना चाहिए ना आपको नेचर ऑफ कर्व क्या है. So right now, what is the nature of my curve here? It's a straight line. It's with a positive slope. So what will be the acceleration? हमने जो 3 केसेस जो लिया था इसमें ये कौन से केस में आएगा? केस 1, केस 2, केस 3. कौन से केस में आएगा ये? क्या मैं कौन से केस में आएगा हमें ये? यूनिफॉर्म वेलोसिटी, यूनिफॉर्म एक्सेलरेशन, वेरिएबल एक्सेलरेशन. कौन सा केस है ये? मेरा आवाज आ रहा है सबको? हेलो.
Yes, sir.
हाँ, तो आंसर क्यों नहीं दे रहे हो? Of the 3 cases that we have discussed, okay, about firstly we have uniform velocity, then we have uniform acceleration, then we have variable acceleration. So in which case does it come? The region between 0 and 10. The first region which is there, that comes in which case? It comes, it is a case of uniform acceleration, right?
Yes.
Then between 10 seconds and 20 seconds, it's my velocity time graph, it is a straight line and it is parallel to the x-axis. So that means the velocity it is constant. Velocity constant मतलब acceleration क्या हुआ आपको?
Zero.
You have zero acceleration, right? Then what about between time 20 seconds and 50 seconds, third region which is there? In my third region, my velocity it is uniformly decreasing, right? My velocity it is uniformly decreasing, and what is the nature of my curve? My nature of my curve, it is a straight line, right? It is having negative slope. So what is that? So what is that case about? Is that a case of uniform velocity? Is that a case of uniform acceleration or variable acceleration?
Uniform acceleration.
Yes, it is a case of uniform acceleration, but there I also have something, right? Because the uniform acceleration, and here it is the acceleration value of acceleration that will be negative, correct?
Yes, sir.
So that's why I call it as retardation, right? The value there it is a case of uniform acceleration, but the value of the magnitude of acceleration which is that will be negative. Now, how do I find out the distance between 0 to 10? We have already told that it is the distance traveled in 10 seconds, which is there. For that part which is there, I'll have to find out the area of the curve under 0 time equal to 0 seconds to time equal to 10 seconds. So what is the area under the curve? Okay, what is the equation? It's a right angle triangle, right?
100. Yes, 100.
It is a right angle triangle, right? So what will be my area then?
Base into half into base into height.
Yes. So do that and give me the answer.
100
meter.
meter.
The distance which is there, that is 100 meters, right?
Yes.
Anybody who did not understand? Okay, Harsh, you can stop presenting.
Hello, am I
Yes, sir.
audible? Hello, please
Yes,
respond.
sir, you are audible.
हेलो, मेरा आवाज आ रहा है?
Yes, sir.
Yes, sir.
Yeah, sorry for the slight mix-up. Okay. I hope I'm clearly audible right now.
Yes, sir.
Fine.
Yes, sir.
मेरे मेरे ऑडियो डिवाइस में इशू था, आपका आवाज मुझे नहीं आ रहा था, so I just sorted it out. Okay, so as we had discussed, okay, as we had just continued our discussion, okay. So here in between 0 to 10, which is there, it's a case of uniform.
Acceleration.
Let me write it here. Okay. So in between 0 to 10, which is there, it is uniform acceleration. Then between 10 to 20, it is the case of uniform velocity. And then between 20 to 50, again, it's a case of uniform acceleration, right? So now in the question, what I have been asked out, firstly, to that find the distance traveled in 10 seconds, which is that. Firstly, I have my displacement, which is there. Okay, so my distance, that is the area under the curve here, right?
Yes.
So just this much. So that will be S equal to half into B into T. So S, which is there, that will be, what is the velocity at the end of that? It's 20, right? So 20 into 10. That I am getting it as 100 meters. Fine. Next, which is there, I am supposed to find out the total distance which is traveled in 50 seconds. So now when I want to find out the total distance, then I have to find out the area under which all
Trapezium.
I have to find out the entire complete area, right? I have to find out the area, complete area. So how do I find that out? Either you can use the equation. Okay, so the total distance travel, which is there, to find out the total distance which is traveled in 50 seconds. Firstly, either I can split this entire into three parts, right? So firstly, I have S0 to 10, then the displacement between 10 and 20, then the displacement between 20 and 50. I can do either that. Okay, so which would be, say, preferable? Or S, otherwise S between 0 to 50, because here I have two parallel sides, right? So it is completely the area under a trapezium. So what is the equation for area under trapezium? We'll take both of them and we'll
Half
see.
into
Hmm?
half into
Half
sum
it-
of parallel sides into height.
Half into sum of parallel sides into height.
Height.
Yeah. So what is the half into sum of the parallel sides? That means my first parallel side, which is that is 50, and the second parallel side, what is this height? What is this length? 20 minus 10, right? So half into 10 plus 50 into what is my height here? 20. So it comes out to be as 600 meters. So now between 0 and 10 we had already seen. Okay, between 0 and 10 we had already found out as 100 meters. Then between 10 and 20, which is that will be
200.
the area under this particular region, right? The area under this region, so that will be 10 into 20, so that is 200 meters. In thirdly, between 20 and 50. So between 20 and 50 means it will be this region. So half into 50 minus 20, that is 30 multiplied by 20. That comes out to be as 300 meters. Okay. So implies now the sum of all the three which is there, that comes out to be as 600 meters. So it is the same. Okay, so we can use any of the formula, but still the preferable one would be taking the order of the individual regions which are. This is also not wrong. This you are free to use any of the methods. The total distance traveled, which is that my total distance traveled in 50 seconds, that is equal to 600 meters. Now, the third part of the question which was there, okay, so I was supposed to find out the retardation, right? Now, to get now this case, I have to, when I was finding out the displacement, when I'm finding out the displacement, right? So at that time, then what happens when I'm finding out the displacement? I am finding out the area under the curve. Now, when I want to find out the retardation, so then what will I be finding out? I'll be finding out the slope of the curve, right? So the slope of the region between t equal to 20 and t equal to 50. So now here in this region, okay, so see, when we were starting to discuss about motion curves yesterday, at that time I said, whenever we are talking about graphical or whenever we are making the motion curve, at that time we are not talking about instantaneous velocity or instantaneous acceleration. We are talking about average velocity, average acceleration. So here also, whatever the retardation that I am actually going to find out, that retardation which is there, that is for this entire region, right? The retardation that I am going to find out, okay, so that will be for this entire region, not just for any one instance here, correct? The retardation between t equal to 20 and t equal to 50. So I'll have to find out the slope. So what is the slope here then? I have V50 minus V20 divided by 50 minus 20, right? The velocity at V2 minus V1 divided by T2 minus T1, simple. So velocity at the 50 seconds minus velocity at 20 seconds. So velocity at the end of 50 seconds, it is shown as 0 in the graph. So 0 minus 20. So that is equal to minus 20 divided by 50 minus 20. So that is 30. So how much is it? Minus 2 by 3. How much is it the value? So this is going to be my retardation. Okay, so this is minus 20 divided by 30. But see, since actually in the question I have already asked as retardation, and by actually using the term retardation, it is already understood that okay, it is reducing. So when I want to write, okay, so I can write the retardation as 0.667 meters per second square. Okay, so I can neglect my sign convention here. If I'm talking about acceleration, okay, the same case, if I'm writing it as acceleration, then I have to write it as minus 0.667 meters per second square. Okay, I want you to understand the difference. When I'm saying that it is retardation, it is already meant that it is the effect which is that is reducing the velocity. Okay, so at what rate is the velocity reducing? At 0.667 meters per second square. Okay. Any question here?
No.
Now the next question is that is very interesting one. Okay, so I want you to take a screenshot of this. A train is that is leaving the station A and it is attaining a speed at the rate of 4 meters per second square for 6 seconds, and then it is at the rate of 6 meters per second square until it is reaching a velocity of 48 meters per second. After this, after reaching 48 meters per second, okay, the velocity remains constant. Then brakes are applied, giving the train a constant deceleration. Okay, stopping it in 6 seconds. I forgot to type that. So let me do one thing. Let me add that. Now, okay, stopping it in 6 seconds. If the total running time between the two stations is that is 40 seconds, I am supposed to plot the acceleration time graph. I am supposed to plot the velocity time graph, and to find out the distance between the two stations. Okay, so here I have all the three cases which are coming. So firstly, the train which is there. Okay. So now here I have to uh, split my entire motion between the two stations which is there. Okay. So my split my entire motion between stations A and B which is there into four parts. In the first part which is there, okay, I want you to go through this question, okay, very carefully. Have you taken the screenshot?
Yes, sir.
Okay. Now because see here, the distance between A and B which is there, okay, motion between A and B is there. What is the total time? My total time it is 40 seconds, right? That is given in the question. Now I have my phase one. Now in the phase one which is there, what is my initial velocity? V0, right? Now it is leaving station A. It is said that it is leaving station A. So there is nothing is given. So what I can assume? I can assume my initial velocity V0 as 0. Okay. So let me take V0 as 0. Then in this region which is there, the first region which is there from V0 to until how much time it is there for 6 seconds, right? So V0 to V6. So V6 which is there, I don't know the velocity. Okay, I am supposed to find out the velocity. Okay, what is given is in this region the acceleration A1 which is there, that is 4 meters per second square, and the total time which is there, that is 6 seconds. Then I have my second phase. So in the second phase which is there, what is the total acceleration for the second phase? A2 which is there. A2 it is given as 6 meters per second square. And for how much time is it? I don't know for how much time is it. But here I have V6 for my phase 2. It's starting at V6. Okay. And at the end of this, okay, so my whatever time it is coming, my velocity which is that base will be 48 meters per second. Then I have phase 3. So in the phase 3 which is there, my velocity is equal to, my velocity it is remaining constant at 48 meters per second. And since the velocity it is constant, what happens in the phase 3? My acceleration it is 0. And for how much time is it going on? Is it going to happen? I don't know for how much time it is going to happen. I have to find that out. Okay. Then I have phase 4. So in the phase 4 which is there, what is happening? It is running for a total time of 6 seconds. So time equal to again 6 seconds. The acceleration in this region, I don't know the acceleration in this region. The initial velocity which was there, my initial velocity it will be 48 meters per second, right? Because nothing is given there. And what is the final velocity which is there at the end of 40 seconds? So V40, the velocity at the end of 40 seconds which is there, stopping it in 6 seconds. So my final velocity which is there, that will be 0 meters per second. So my motion it is starting at 0 and it is ending at 0. So in between I have some different velocities. There are different accelerations and for different time duration. So how do I plot it? Okay. So there I have to use some mathematics also and some graphical also. The total time which is there, okay, so if I'm writing it as okay T1, T2, T3 and T4. Okay, so I have T1 plus T2 plus T3 plus T4. The sum of all of four of them, that is going to be as 40 seconds. Okay, so now what makes actually this question interesting? I have many regions where I do not know the velocity. I have one region where I do not know the acceleration, but yeah, that is easier to find out. Okay, that is easier to find out because here I have know the velocities, right? I know what is my change in velocity, and I know for how much time it is going to happen. So now I have at the end of 40 seconds it is going to be at 0, and this deceleration which is that is going to happen for 6 seconds. So how much is this time here? This time here it will be 40 minus 6, right? So how much it will be? 34. So this which is there, my deceleration which is there, that is starting at 34 seconds. Okay. Understood? First part. So let us see that where all we know we know the where we know the values. Okay, where all we can, at least we can try to find out the values, and then we'll try to plot the graph. Okay. So now, firstly, let me So here what I'll be doing is that I'll be plotting my acceleration graph which is there. Okay, acceleration in terms of meters per second square. And here I have t in term t, the unit it is second. Again I have t, unit is second. And here I have velocity, okay, in mean meters per second. Okay. Now let me try to plot it region wise. Now initially what is there? Okay, so I have v0 which is it is 0. Firstly, I have acceleration as 4 meters per second square, and that is for a region of 6 seconds, right? Acceleration equal to 4.1 meter, 4 meters per second square for a duration of 6 seconds. Now here, okay, so my acceleration which is there, has it been given that my acceleration which is there, it is uniformly increasing, uniformly variable acceleration, or this is this a case of uniform acceleration or variable acceleration? This part which is here given here, what do you think? Attains speed at the rate of 4 meters per second square which is given. So is this a case for uniform acceleration or for variable acceleration?
Uniform acceleration.
Why do you think so?
Sir, क्योंकि in this part the acceleration is constantly increasing up to
It
6.
can, that my acceleration can increase, right? Acceleration can increase from 0 to 4 also, right?
Yes, sir.
Why is that not possible?
So it's a variable acceleration.
नहीं, पहले जो बोला वो करेक्ट है. इट इज अ केस ऑफ यूनिफॉर्म एक्सेलरेशन. ओके, दैट इज करेक्ट. बट सी, मैं अगर लॉजिकली देखूंगा, अगर हम लोग लोकल का भी अगर देखते हैं, ओके, सो देयर व्हाट हैपेंस, द ट्रेन एज सून एज इट इज लीविंग द स्टेशन, ओके, एज इट इज लीविंग द प्लेटफॉर्म, दैट इज नॉट अटेनिंग द acceleration straight away, right? Firstly, there is a phase of there is a case of variable acceleration. Then after some time, there is a case of uniform acceleration, right?
But sir, in the question there is clear na they
Yes.
leaving a train A attain a speed at the rate of 4 meter per second square. That's why it
Yes.
means it's a
Yes. My
uniform.
velocity which is there, it is going to be at, and yes, it is a case of uniform acceleration. Okay. So how do I plot uniform acceleration then? When I want to plot the uniform acceleration, how am I going to do that? So from here itself, okay. So it will be, what is the, how do I plot uniform acceleration? A straight line with positive line which is parallel to the axis, right? It is parallel to time. So here which is there, okay, so between t equal to 0, so here it will be t equal to 0, and say here it is up to t equal to 6 seconds which is there. So in this region my acceleration which is there, that is 4 meters per second. So I'll be plotting it like this. And when I have the case, such a case, okay, so what happens to my velocity? What happens to my velocity? Velocity is starting at 0, okay, for time equal to 6 seconds. तो यहाँ पे मुझे at the, so what will be the velocity at the end of this, right? What will be the velocity at the end of at 6 seconds? मुझे velocity क्या रहेगा? That will be the area under this curve, right? Yes or no? At the end of
Yes,
6
sir.
seconds, what will be the velocity? The velocity will be the area under this graph. What is the area under this graph here? 4 into 6, 24, correct? So at the end of 6 seconds, which is there, my velocity, which is that is going to be 24 meters per second. तो मैंने क्या किया, अभी यहाँ पे मैंने 0 मार्क किया. Here my t is 6 seconds, and let me mark my velocity here. Okay, so my velocity here it was. Let me mark it. So this here which is there. Okay, so this is 24. So ये region में whenever it is a case of uniform acceleration, what will be the shape for my velocity time graph?
Straight line
Straight line with slope.
with a positive slope.
Yes, it has to be an inclined line, right? Now, what about my displacement time graph for the same motion? What will be the displacement time graph?
Parabolic.
It will be my ST, which is there. Okay, so my ST curve, if I'm making, okay, so that will be parabolic in this region. Okay, yes. So here, my first region, which is there, that is a straight line. Then, in the next region, which is there, okay, now the acceleration, it is increasing to 6 meters per second square. And what is the velocity now? So my V6, I know here. What is my V6 here? 24 meters per second, right? So now the velocity is increasing in the second phase, which is where my velocity is increasing from 24 to 48 at the rate of 6 meters per second square. So for how much time will it be happening? This acceleration is for how much time duration then? T2, it will be 48 minus 24 divided by 6, correct?
Yes, sir.
So because हम लोग को
Okay.
basic equation हमको पता है ना, acceleration which is
V equals to
that is
V.
delta v by delta t ना,
Yes, sir.
acceleration is delta v by delta t. तो मुझे जब delta t निकालना है तो it will be delta t, it will be delta v upon a, correct? So delta t equal to delta v upon a. तो वही हमने यहाँ पे किया है. So here what will the value, what is the value that I get for t2? 4 seconds. So at the end of phase 2, what is my total time? What is the total time? 6
10.
plus 4, right? 10. So ये भी यहाँ पे मुझे क्या लिखना पड़ेगा? 10 लिखना पड़ेगा ना? Okay. Are you understanding? हम लोग ग्राफ और ये हम लोग दोनों साथ में कर रहे हैं, ठीक है? So now the phase 2 when I am plotting, okay, so at that phase 2 my acceleration which is that is at 6 meters per second square, and that is happening for a time duration of 4 seconds. So now let me mark 6 meters per second square, which is that. Now at the end of 6 seconds, which is that, okay, so मुझे इसको यहाँ पे let me extend this here. Now at the end of 6 seconds, which is where my velocity is attained is as 48 meters per second. So this was 24. So now here it will be 48, right? So ये point मैंने mark किया. And now in this region, which you see, I want you to see that yeah, the slope which is there, it is again a straight line with positive slope, which is there, an inclined line. But this time my slope which is there, it is steeper. My line it is steeper. यहाँ पे मुझे ये इसका slope कितना था? 4 meters per second square था ना यहाँ पे slope. यहाँ पे मेरा slope कितना आना चाहिए? 6 meters per second square आना चाहिए. So that's why it's a steeper slope here. And here, what is the time at the end of that? It is the total time which is that is 10 seconds. Now the next part which is there, okay, so that is the most crucial one. I have a region here, okay, so wherein now I have between velocity equal to 10 seconds, that is 48 meters per second, and now this region which is there. Okay, so at the start of phase 4, what is my velocity? Velocity is at 34 seconds, right? So 40 minus 6 is 34. तो यहाँ पे मुझे v at 34 which is that is at 48 meters per second. So v10 minus v34 minus v10, मुझे ये कितना हो गया? टाइम ड्यूरेशन कितना हो गया मुझे यहाँ पे ये रीजन में?
1.
हाँ, 34
One.
minus 10, right? 24 seconds. अंडरस्टैंड? मैं यहाँ पे टाइम देख रहा हूँ। 34 में मुझे 34 में मेरा फोर्थ फेज शुरू हुआ है एंड सेकेंड फेज मेरा खत्म कब हुआ है? 10. So what is the time duration for the third phase where I am having constant velocity? 34 seconds minus 10 seconds. So the total time which is that is 24 seconds.
Yes.
Okay? Understand? अगर क्वेश्चन है तो पूछो।
सर वो रिपीट करो ना, नहीं समझा V34 वाला।
देख यहाँ पे मेरा my velocity, the fourth phase of the motion which is here, okay, at the fourth phase of motion at the end of 40 seconds बोल के मुझे दिया है क्वेश्चन में, right? At the end, if the total running time between the two stations is 40 seconds बोल के दिया है, so 40 seconds में से मुझे 6 seconds अभी बॉडी अगर मेरा ये अगर 6 seconds के लिए ये हो रहा है, constant deceleration हो रहा है, okay, so what will be the start of this deceleration? 40 minus 6, 34. So the start of the fourth phase of motion, that will be the end of the third phase of motion, correct?
Yes sir.
तो मेरा थर्ड फेज में मुझे यहाँ पे क्या हो गया? 34 सेकेंड्स हो गया। एंड व्हेन डज द थर्ड फेज स्टार्ट? द कांस्टेंट वेलोसिटी का फेज कब शुरू हो रहा है मुझे? एट आफ्टर 6 सेकेंड, आफ्टर 6 plus 4, आफ्टर 10 सेकेंड। तो मेरा थर्ड फेज कितना है? कांस्टेंट वेलोसिटी का ड्यूरेशन क्या हो गया? फ्रॉम 10 सेकेंड्स टू 34 सेकेंड्स। टोटल कितना है? फ्रॉम 10 to 34. So 34 minus 10, the total time duration for my third phase, that is 24 seconds. Okay, now understood? Now what is the retardation? What is my deceleration in this region which is that? वो भी मुझे बाकी है अभी. Okay, so now okay, let me do one thing in the same way.
8,
Okay,
sir. 8.
Yeah, 8 or minus 8.
Minus 8. Since it is
Acceleration
written
time graph.
retardation
Acceleration.
to 8
Yes. एक्सेलरेशन टाइम ग्राफ में जब मुझे दिखाना है तो मुझे क्या दिखाना पड़ेगा? मुझे -8 दिखाना पड़ेगा। ओके,
Yes, sir.
so now next which is there between 10 and between 34 which is there. Okay, so in this region now I have, it is my
Zero
acceleration which is there, and my acceleration it is 0. Then the same मैं 34 को मैं इधर में प्लॉट लिया मैंने नीचे में, क्या बात है? नियरली स्ट्रेट लाइन आ गया ना? नियरली स्ट्रेट लाइन आ गया, अच्छी बात है। This is a region of constant velocity, constant uniform. This is a region of uniform velocity, right? And what is the end? At the end of the uniform velocity, what is the time duration? That is 34 seconds. Next, here which is there, my velocity is changing from 48 to 0. So A4 that is equal to 0 minus 48 divided by 6. So that is coming as -8. So A4 which is that is -8 meters per second square. अभी ये -8 में कैसे मार्क करूंगा? I'll be marking on the negative y-axis below the y-x axis which is there. तो यहाँ से मैं -8 मुझे लेना पड़ेगा. Then and then this is happening for a time duration of 6 seconds, right? So time duration, it is happening for a time duration of 6 seconds. And यहाँ पे भी इसका स्लोप जो है नेगेटिव स्लोप, and this is again, this is going to be a straight line. तो यहाँ पे ये at the end of that, what is my time here? 40. Here 40. Okay, so this just by reading those values, just by my analysis, okay, so I am able to plot my acceleration time graph, and I am able to plot my velocity time graph. Okay, now in this, okay, so now what I'll do is that I'll highlight my region which is there, because we have a lot of lines here. Okay, so let me highlight the region. My first phase where acceleration is 0 to 4, my acceleration is 4 meters per second square for a duration of 6 seconds. Next, after that, immediately after that, it is an acceleration is increasing to 6 meters per second square for a duration of 4 seconds. Then I have a uniform velocity for the next 24 seconds. So at uniform velocity means I have my acceleration as 0. So that's why I'm marking the next 24 seconds line which is there on the x-axis. Then I have a deceleration of 8 meters per second square. So below the x-axis, I'm showing 8 meters per 8 meters per second square. I'm showing. Okay. So at the end, so this is my acceleration time graph. What about my velocity time graph then? For 0 to 6 seconds, it is first increasing at the rate of 4 meters per second square. Then it is increasing again at the rate of 6 meters per second square. Then I am having uniform velocity for a duration of 24 seconds, and I have constant deceleration at 8 meters per second square. If I want, okay, so what I can do is that I have written S here. Okay, so what I can also write here is that the slope here 4 meters per second square. Then here, what is my slope? 6 meters per second square. Here 0 meters per second square. Here it is at minus 8 meters per second square. Okay, or you can not necessary to write minus also there. You can, because it is showing negative slope. Okay, so that means it is reducing. It is reducing at the rate of 8 meters per second square. Okay, any question until now?
Sir,
Yeah,
sir, if we combine phase one and phase two, then we will have a variable acceleration. No?
phase one and phase, if you are combining, yes, if
Again, it was power out. It was power loss. Okay. So now until now, okay, we have completed. Now the phase that we have have to complete. Okay, right now it is about finding out the total distance between A stations, A and B, which is there. Now, how do I find out the total distance between A and B?
So we will take whole area under the velocity time graph.
Yes, I'm not asked to plot the velocity time graph. I'm not asked to plot my displacement time graph. Okay. So in this case, if I want to plot, if at all I want to plot my displacement time graph, what will be the nature of curve at each of these phases?
So initial will be parabolic, then it will be s- I mean a uniform straight line along with an inclination, and then it
In
will be
phase
a
one and phase two. Okay. In phase one and two, it is going to be parabolic, right?
yes sir.
Yes, sir.
In phase
Then
three,
it's going
in
to be
phase
an
three,
inclination of straight line
it is
for
going to be
distance time graph, inclined straight line with a positive slope, and
yes. And phase four.
then yes, and for phase four it will be a parabola, but that will be a downward parabola. I mean, which will be in, below the x-axis, we can say, if we have to refer it individually, or you can say just a bowl shape.
Yes. Okay. So if you want, okay, for your sake of understanding, for your understanding, okay, so you can try to plot the velocity, you can try to plot the displacement time graph, okay, no problem. And now to find out the total distance traveled which is there, so what you will have to do, you have to take the area under the velocity time graph, the total area under my velocity time graph, okay. Find out, okay, so just do the calculation and tell me what is my total area under the velocity time graph, and then we'll stop, okay. Now for my phase one which is there, for phase one it will be my velocity time graph, it is a right angle triangle, right? Phase one it is a right angle triangle, phase two it is a trapezium, then phase three it is again it's a rectangle, and phase four it is again a right angle triangle, correct? Hello.
Yes, sir.
Hello. In phase one, which is there, it is going to be with positive slope. In phase two, it will be sorry, what will be my total area under the curve? Quickly. Hello. Okay, so the total which is there, my total distance travel which is there, that is coming as 1512 meters. Okay, the total distance which is there between t equal to 0 seconds and t equal to 40 seconds, the total time which is the total distance travel between it is coming as 1512 meters. Okay, all of you please give your attendance, and if you are not giving your attendance, then don't. Okay, it is your responsibility to give your attendance at the time. Okay, if you are not giving, and or if you are giving your attendance after it is the meet is closed, okay, so that will not be considered. Okay, आपका attendance आपकी जिम्मेदारी है.
So 1512, na?
Yeah, 1512.
Yeah, correct, sir.
Thank you.
No, sir. Thank you to you.
Okay, so you can give, if you are done. Okay, so you can give your attendance and leave the meeting.